Okay, this is part two of motor starters, and in the last video I went over the basics of motor starters. And one of the things I did go look up was the terminal number on normally closed contact. This is terminal 95. And 96. Not exactly sure what the normally open contact is, but I think it's in the 90s as well. Okay, so we talked about how motor starters were again, just very much like a relay. You close a set of contacts and you energize a coil, and a set of contacts change state. Okay. The overload contact changes state when the overload heaters that we discussed, there they go, right here, when the heaters heat up, this is for overload protection. Okay, that's why they're called an overload block. Put those two together as it's shown there, and you have a motor starter. Okay. We also talked a little bit the last time about power diagrams, and then this is a control diagram, which is everything that we've been working on so far. So now we're going to combine the two. Now, we really did power diagrams in previous labs when we did DC motors and three-phase induction motors. We just didn't so much call out those diagrams, but we'll begin to call those out. The next 2 weeks here, we're going to be doing labs using motor starters. We're going to start out with our DC motor again, and let's just look at a regular start-stop circuit. I did pull the lab up, and let's take a look and see what kind of control it uses. Two-wire control. So that's what we'll take a look at. So let's go take a look at our DC motor from the past. Here's the diagram that we've used in the past. Let me make it a little bit bigger. And we are not so much controlled or concerned with the Sta-Co power supply and all that. Really what I wanted to bring back to your attention was our basic DC motor, or our basic shunt motor, consists of the shunt field and the armature. And so I'm going to go ahead and draw that here. Remember, the shunt field's F1 and F2, and the armature A1 and A2. And if we apply DC power there at this moment in time, plus or minus top to bottom there, 120 volts, our motor will run. Okay, so we need a 120 volt power supply, DC, which we get from the Sta-Cos. Okay. Then for a DC motor, we're just going to use two contacts of our three-phase motor starter, and we're going to include the overloads, and there they are. You always want to make sure you identify the contacts. Now, this is in the power diagram. Now, in DC motor control, there's no connection between the DC power and the control circuit other than these contacts. And these contacts are rated for both AC and DC voltage. And in this case, we're just, I think it's up to 250 volts, or maybe even, yeah, probably 250 volts DC. We're putting 120 volts DC through them. And up to 18 amps, I think, or something like that. Okay, so that's the power diagram for the DC motor. Then the control diagram, we're going to come off of our transformer like we always do, through our fuses, over to L1 and neutral. And we talked, how many times have we talked about two-wire control? We're just going to plug in two-wire control here. We're going to use our three-position switch as a just a regular on-off two-position switch. Then we wire this to 1M, and then there's our overload contact. Okay. Now let's go back and identify the contacts here, or the terminals, like we normally do. Again, 7 for our selector switch. We want to go into 7, and then if we could go out of either 5 or 6, I'll use 5 on the other side. Then this is A1 on the motor starter, A2 on the motor starter. Then the overload contacts are terminals 95 and 96 on the motor starter itself. Again, those contacts are right there. I'm pretty sure the 2 on the left. Okay. On the motor starter itself. Okay. The other thing we want to remember is up here, L1, and you could use L2 or L3, and then T1 and T2. Okay. And we got, it's kind of hard to tell here. We'd have to roll this over the block back to see that down below there's 3 terminals, T1, T2, and T3. And that gives us our motor starter. And I think that's everything. And so this is then our control diagram. 2-wire control. Okay? Now we might go into some other types of control in that lab. I don't really remember. But get this wired up correctly, and we can start and stop that DC motor with a motor starter. Now what I'd like to do is talk about 3-phase induction motors. And remember, our 3-phase induction motor is just 3 terminals. I think they're labeled 1, 2, and 3 on the motor itself. We got 3-phase power from the board. Now, we're not going to do that this time. On the control board, we have 3-phase power, where our power cord comes into our board. So, let's take a look at 3-phase induction motors. And we just draw these as 3 lines. Let me draw the power diagram first. Okay. And so we plug in our board, and this would represent the fuse disconnect that is on the control board itself, where the 3-phase plug comes in. Then that 3-phase, in addition to going down to the transformer, goes up to 3 sets of terminal blocks. Now, some of you have 3-phase terminals. Some of you have shown this. I don't know if you remember that or not. Okay, but it's not the same terminal blocks as the control power. They have 208 between them. There's 3 sets of 5 terminals that are separated by a divider that give you ABC, and I would reference them ABC from left to right. And we're going to run wires from that 3-phase power down to our motor starter, L1, L2, and L3 terminals, then they go through the overloads. Now, we do not have to make this connection right here to the overload. That's already done. I didn't point that out earlier. That's what's done here when we put them together, okay? And then, again, the other end of the overload then gives us T1, T2, and T3. And then this would go out to the motor. And again, we're ready to put in control power. Now, this would be, again, M1 motor starter, or 1M. This should be M1. This is the overload contact also. Okay. And then let's go ahead now. Our transformer is actually connected to our circuit now. Got a fuse in there. And a fuse. Okay. And let's go see which what we want to start out with the three-phase induction motor. Start with 3-wire. So 3-wire control now here with the start-stop push button station on the induction motor itself. Now again, remember this is 3-wire control, so you really want to understand the difference between 2-wire, 3-wire, and we're going to talk about handoff auto here in a second. So with 3-wire control, we have a normally closed stop button. We have a normally open start button. And we have M1 relay, the overload contact, and then we need a seal-in contact. And how do we accomplish that? And that is accomplished with auxiliary contact. So here's a diagram out of the data sheet for these Fuji motor starters and contactors. And we have equipped our motor starter with an auxiliary contact block. Now, be careful with this because there are actually 4 terminals. There's 2 contacts on there. There's a normally open and there's a normally closed. And terminals 83 and 84 are the normally open contact. I do not remember what the normally closed is. So on the side of the, I think they're the back terminals if I remember right, the bottom terminals. On the side of the motor starter is that auxiliary contact block. Terminals 83 and 84 you'll use as your seal line contact. So if we go back through here and put terminals on 1, 2 for the stop button, 3, 4 for the start button, the motor starter A1 and A2, and again, those A1 and A2 terminals are right there. And you can see a little bit better right here. Okay. Yeah. Okay. And I guess I do believe that we have completed 3-wire control for a 3-phase motor. And again, 3-wire control, you hit the start button, M1 picks up, and this M1 auxiliary contact closes, sealing it around the start button, and M1 main contacts 1, 2, and 3 there close in, and the motor starts. And again, the way the overload works is, according to the time current characteristic curve, if we get I line big enough, larger than I rated, okay, these guys will heat up. Each one of these will heat up and will eventually open that contact. And with 3-wire control, it drops everything out. So that contact, auxiliary contact, opens back up, and one drops out, and it shuts the motor off. And that's for overload protection. Okay, very good. Again, here's our power diagram. And our control diagram. And I separate these diagram with that dotted line. Okay. All right. The last thing I want to go into then is what we call handoff auto control. Okay. For a 3-phase induction motor, it'd be the same power diagram. And let me just go ahead and redraw that. So we'll start with our 3-phase fuse disconnect switch. Come over here to our contact and overload. To our motor. Put my terminals on here. And I know this is going to go to M1 motor starter. Okay, and again, there's our power diagram. To our transformer. And power control. Okay. Now, literally, you know, in the real world, the power diagram can be 5 kV stuff, 15 kV stuff, okay, and all controlled by 120 volts AC. A lot of power companies use 250 volts DC for control. Okay, so this is really, in my mind, this really opens up a whole new world. But let's talk about handoff auto. Well, handoff auto requires a 3-position selector switch. So let's start by just talking about, let's just call it hand and off. We'll put our motor starter coil in here. Okay. And so 95 and 96 on the overload, A2 from the motor starter, A1, okay, and this is M1. And then, of course, we've got 2-wire control, or on-off control of a 3-phase induction motor. Now, what happens with handoff auto is you have the 3rd position. So let's go ahead and draw in the terminals. This is why I've been emphasizing this has to be terminal 7 coming into our 3-position selector switch. And 5 and 6 can be backwards here, but we have to go into 7. And then right here, we have what's called our auto position. So this is called handoff auto, okay? And what makes up that auto contact there can be just a variety of things. And I think in the lab we just make it a push button. But we also like to talk at this time about, I can't remember whether it's chapter 5 or 6, but it goes into various I/O. The other thing I like to do at this point is go into various I/O devices, okay? And so let's just mention them. This could be a temperature switch. There's a normally open temperature switch. There's a normally closed temperature switch. So this is temp. And these are just switches, okay? And it may have like if we're in a home, you know, if we set the thermostat to 70 degrees, that thing's going to kick on and off at 70 degrees, okay? And most of them have hysteresis built into them, so they'll kick on at 68 and off at 72, okay? That's usually built into the they call it the dead band. Okay, and this is just an example. So most switches have some dead band built into them, so they just don't sit there and cycle back and forth real fast. Other ones we want to talk about that I think are important are these are called double switches, normally open, normally closed, level, pressure switches. They are half a circle, pressure switches are. And these are all in the back of your textbook. And we will use them from time to time. And so this is pressure. Okay. They could be flow devices, flow switches. Flow switch has a little flag, upside down flag. And I forget which side the flag's on, but this is flow. They could be limit switches. We'll talk a little bit more about limit switches. Limit switches are like the switches in your car door that make your lights go on and off. So this is what we call limit switch. And the good thing is these things really just operate like a push button. It's just a matter of what's making them operate. Is it a quantity like temperature, level, or flow, or mechanical like it is in a limit switch? Now the other thing we're going to use that we're going to introduce you to later on is proxies and photo eyes. And for the time being, we're just going to use the same symbol. Looks like a limit switch, only it puts a diamond around it. Proximities and photos. And we'll learn about how those work. But any one of those could go in there in that auto slot. I think we're just going to use a push button. I'll have to look and see if we have proximity switches in the cabinet. I know I meant to order some. If we do, maybe we'll use proximity switches. But let's talk about how this works. So a lot of times these control stations, this is what I mean by a control station. Most of the time they just look like our little push button stations that are mounted on our boards or the ones that are remote. And the automatic switch is not there, but the actual motor starter, it can be hundreds of feet away from where the motor is, but oftentimes these control stations are put out with the motor wherever it's at. So you can walk up, you can see the motor, whatever you're trying to pump or move, and you can, an operator, usually not an electrical guy, but an operator will go up to the hand station. If they want to make it run, they can turn it to hand and make it run. Okay? If they're satisfied with what they got and they're ready to go back to automatic control, they can flip it back to automatic, and now whatever's controlling the motor automatically will control the motor. It could be a level switch. A lot of times these are like tanks of material. And so they will, once they get to a particular level, they will kick on, the level goes back down, they'll kick back off, okay? And so that's handoff auto. So let's draw just a couple of examples here. Just using the control diagram, and a motor starter and an overload. And let's just do a normally open. So here's a normally open level switch or float switch. Okay, so and let's say that I've got a tank of water here, and this level switch here is located up here at the top. Okay, and so an operator can go out, like I said, you'll have, maybe you've got a tank, and our motor is running this pump. Okay, and you got a selector switch, maybe a light, but a push button station here that just has our handoff auto selector switch in it. Mr. Harstein goes out there with his hard hat on and his safety glasses and his steel-toed shoes. And so we can not necessarily, there's probably level indication on the side of the tank, okay? So he knows where the level's at, and maybe he wants to run that down, so he just turns it on and pumps material out wherever it's supposed to go. Then he turns it back. We decide to turn it back into auto position, and of course, somewhere in the process, we're putting material into this, and so this is kind of like overflow protection. So it gets up so high, and if we put it in auto position, this normally open contact will close, kick on the motor, and again, whatever dead band is in there, let's say that our dead band is from level 1 to level 2. If it does get too high, this will keep the level in that tank between level 1 and level 2. We call that dead band. Okay? So that's a good example of handoff auto. Okay, let me give you another great example. Most people don't call this handoff auto, but it's the same scenario. So let's say that we've got a similar situation. Okay, motor starter and our overload, and we've got handoff operation to our control there, but in addition now, we wire a control contact. Now, for those of you that have done PLCs, this can be a PLC contact. What you haven't heard of probably is what's called a DCS contact. DCS stands for Distributed Control System. Now, in recent years, the division between PLCs and DCS have really gotten cloudy. Because especially Allen Bradley, I don't know if everybody else is, but Allen Bradley's latest platform, their ControlLogix platform, which for you guys is all you've probably ever known, was really built to compete with DCS systems. And we have remote I/O racks and all that kind of wonderful stuff. It's really cool what is developed in those areas. But anyway, the bottom line is it can be a PLC. Now, with a PLC, so we've got and I'm going to talk about an OW4 card. On an OW4 card, we got a couple of terminals where, let me call this just terminals PLC1 and PLC2. So PLC2 and PLC1. Okay. Now that contact then is controlled by a ladder diagram. In a PLC program. Typically, it can be controlled a lot of different ways, but that's what you're most accustomed to. And then we can also take that out to an HMI, which is Human Machine Interface. And we'll do a little bit of this. Just a little bit of it at the end of this semester. These are panel views. Allen Bradley makes a device called a panel view. The other thing is with Ethernet connectivity now, if we have the right communication protocols, we can communicate with that thing from anywhere. So this is, when you do something like this, they usually refer to it as remote operation, because it can be done from a control room with a plant, or it can be done, like with water treatment plants where, and what they call lift stations. This might be done across somebody's phone with the right communication protocols. Okay. So this is really opening up a whole new world in my mind. So hopefully you got something out of that, and that is motor starters.